sound day. Dear grade 8 learners, I know that all is well as we explore the wonders of Science 8 for Quarter 3, Week 1. I am Teacher Mary Ann, your science teacher who will guide you for today's lesson. Before we proceed, please be reminded of our science rules which I dub as BTS. B. Be sure that you are in your most comfortable learning environment or conducive learning zones. T. Take down important notes and insights because you need this in your studies. S. Seek assistance from your teachers, parents, household members, and peers in case you need help. These rules should be your guide as we learn trends and explore the world of science. Imagine that we are traveling across the universe. Earth, one of the most unique planets in the universe, as it overflows with life animals, plants, and human life. Its verdant forests, rolling hills are God's carpet on earth. These are filled with fruit-bearing trees and flowers, plants that mankind could harvest and be of great service to the world. The rivers, oceans, and seas provide the planet with fish, shells, and other marine life. The air is where birds of numerous variety fly freely. The land is where animals live and multiply. The clouds that float like cotton yield rainfall that nourishes the soil. Indeed, ours is a beautiful planet, and what makes extra special is the presence of life. There are God gifts that have to be protected and preserved. However, we should also take space to learn and understand its properties, features, and composition. Have you experienced dropping a stone into a glass? Would anything happen to the shape or size of the stone? Would the shape or size of the stone change if you put it in a larger pail? How about transferring the soft drink from a small container to a large one? What do you think would change about soft drink if you poured the soft drink to a glass? Would the volume of soft drink be different? Would the soft drink change? Would you believe that a single small tank of helium can fully loaded almost 700 balloons? How is this possible? Did you know that Leucoppus and Democritus had an idea that atoms have a particle that surround them but have no concrete size and shape? Indeed, Maryam believed that atoms are physical in nature but had no shape at all. Likewise, John Dalton was able to concretize evidence that atom is a particle that cannot be seen by our naked eye. He was able to present and found out the best evidence that matter is made up of tiny particles. Particles of matter are kept on moving all the time, but they differ in its movements as to the state of matter. These particles have spaces between them, and thus it attracts one another. Observations support the theory of matter is made up of particles are the following. Just like John Dalton's concept on matter, it is made up of tiny particles. Particles of matter are moving all the time. These particles have spaces between them. The particles of matter attract each other. To know more about it, let us explain thoroughly the situations presented. What happened to the shape or size of the stone after being dropped into a glass, or would the shape or size of the stone change if it was put in a larger pail? The stone shape and volume stay the same no matter what size of the stone you drop it into because the stone is a solid. A solid is the state of matter that has a definite shape and volume. Solids are less compressible. The particles of a substance in a solid state are very close together. The solids are packed closely together. They vibrate a little in place but in fixed position. They are locked in place by particles around it. They do not move fast enough the traction between them. What do you think would change about soft drink if you pour the soft drink to a glass? Would the volume of soft drink be different? Would the taste of the soft drink change? The only thing that will change when the soft drink is poured into the glass is the shape of the soft drink. The shape changes because soft drink is a liquid. Liquid is the state of matter that has a definite volume but takes the shape of its container. The particles in liquids move fast enough to overcome some of the attraction between them. Although liquids change shape, they do not easily change volume. A soft drink contains a certain volume of liquid. That volume stays the same if you pour the soft drink into a large container or a small one. In addition, liquids have unique characteristics. A special property of liquids is the surface tension. Surface tension is a force that acts on the particles at the surface of a liquid. Surface tension causes some liquids to form spherical drops like the beads of water. Take note, different liquids have different surface tensions. Another important property of liquids is viscosity. Viscosity is a liquid's resistance to flow. Usually, the stronger the attractions between the particles of a liquid, the more viscous the liquid is. Would you believe that single small tank of helium can fully loaded almost 700 balloons? How is this possible? The answer has to do with gas, state of matter. Helium is a kind of gas. Gas is the state of matter that has no definite shape or volume. The particles of gas move very quick and fast, so they can break away completely from one another. There is no attraction between particles of a gas than between particles of the same element in the solid or liquid state. The position of empty space between gas particles is not fixed. The particles of helium in the balloons are very far from each other than the particles of helium in the tank. The particles scatter out as helium fills the balloon. So, the position of empty space between the gas particles increases. These concepts are some of the features of what scientists call the particle model of matter. To have a closer understanding about the properties of gases, liquids, and solids, remember the following insights. I'm sure that you understood our lesson well. This time, let's have a comprehension check. Don't worry, dear learners. I will show you and read the questions twice. I will give a 5-second timer after each item to decide your final answer, and we will reveal the answers immediately. Are you excited? If so, let's begin. Question number 1. How does particles of liquid are attracted to each other? A. Stay in place. B. Move fast enough to overcome almost all attraction in them. C. Move so slow to overcome some attraction between them. D. Move fast enough to overcome some attraction between them. I'll repeat. How does particles of liquid are attracted to each other? A. Stay in place. B. Move fast enough to overcome almost all attraction in them. C. Move so slow to overcome some attraction between them. D. Move fast enough to overcome some attraction between them. The correct answer is letter C. Very good. Question number 2. Inside the shoebox are filled with paper balls. Even you kept on holding the box upside down, still they cannot move away from each other. What happened to the particles or the paper ball? A. Particles are kept on moving around. B. Particles have lots of free between them. C. Particles have a little free space between them. D. Particles are very close to each other and locked into place. I'll repeat. Inside the shoebox are filled with paper balls. Even you kept on holding the box upside down, still they cannot move away from each other. What happened to the particles or the paper ball? A. Particles are kept on moving around. B. Particles have lots of free between them. C. Particles have a little free space between them. D. Particles are very close to each other and locked into place. The correct answer is letter D. You're still on the right track. Question number 3. Which statement is true about aspects of the particle model of matter? A. Matter is made up of bigger particles. B. Particles of matter are not moving all the time. C. Particles of matter do not attract each other. D. Particles of matter have spaces between them. I'll repeat. Which statement is true about the aspects of the particle model of matter? A. Matter is made up of bigger particles. B. Particles of matter are not moving all the time. C. Particles of matter do not attract each other. D. Particles of matter have spaces between them. The correct answer is letter D. Nice job! Question number 4. How does particles of gas are attracted to each other? A. Move and stay in different stations. B. Move fast enough to overcome some attraction between them. C. Do not move fast enough to overcome the strong attraction. D. Move fast enough to overcome all of the attraction between them. I'll repeat. How does particles of gas are attracted to each other? A. Move and stay in different stations. B. Move fast enough to overcome some attraction between them. C. Do not move fast enough to overcome the strong attraction. D. Move fast enough to overcome all of the attraction between them. The correct answer is letter D. That was awesome! Question number 5. What is the microscopic explanation why liquids easily flow? A. Very close to each other. B. Rigid particles lock into place. C. The particles of liquids move fast one another. D. The particles in liquids move fast enough to overcome some of the attraction between them. What is the microscopic explanation why liquids easily flow? A. Very close to each other. B. Rigid particles lock into place. C. The particles of liquids move fast one another. D. The particles in liquids move fast enough to overcome some of the attraction between them. The correct answer is letter D. You did it well. Congratulations for getting a perfect score. That was a great learning experience, dear grade 8 learners. You already know that atoms are smallest particles of every matter. Matter concept, according to John Dalton, it is made up of tiny particles. Particles of matter are moving all the time. These particles have spaces between them. The particles of matter attract each other. State of matter is the physical forms in which a substance can exist. Remember that there are 3 kinds of matter: gases, liquids, and solids. Each has unique features and characteristics. Take note that gas is the state of matter that has no definite shape or volume. Gases assume the shape and volume of its container. Its particles can move past one another. It is compressible. There are lots of free spaces between particles and it flows easily. On the other hand, liquid is the state of matter that has a definite volume but takes the shape of its container. Liquids assume the shape of the part of the container which it occupies. Its particles can move or slide past one another. Liquid is not compressible. It has liquid free space and it flows easily. The last one is the solid. Solid is the state of matter that has definite shape and volume. Solid's microscopic explanations retains a fixed volume and shape. It has rigid particle locked into place, not compressible, unnoticeable space between particles, and does not flow. In a nutshell, let us strive to be responsible citizens of the world through using those state of matter the way it should be. Let us fill the air we breathe with love and affection, and taking space like particles to connect and move. Again, this is Teacher Mary Ann saying, let us keep the love alive between mankind and matter. When we endeavor to start exploring the wonders of matter, it provides for us all the more. Let us make a matter of manner and put a manner in matter. See you again in our next episode. Keep safe and stay home.